So today we're going to be talking about the last lesson in this unit, and we're going to go over a challenge problem from a PSAT book. So if we look at this, given f of x equals 2x squared plus ax minus 3, determine the value of a if the function includes the point 449. So the first thing that we're going to do is plug in 4 to x and 49 to y. So that's all I did to get from here to here. I still have my a, and we're trying to determine the value of a. So I do 4 squared first, order of operations. So 4 times 4 is 16, and 16 times 2 is 32, and then we bring everything else down. Now a times 4 is the same thing as 4 times a, and we always put the number in front of the variable, which is called the coefficient. We put that first. And then we combine like terms, subtract 29, and divide by 4. So a is 5. Okay, and then this, remember from the last unit, so first of all, we're given g of x equals negative 3x plus 6, and this table, which notice this table is h of x, and we're going to determine h of g of x plus 3. So this is how we can write it in simplified form if x equals negative 1. So the first thing that we're going to do is plug negative 1 in for x. They give us what x is, so let's plug that in. Negative 1 plus 3 is 2. And now we start from the inside and go out. So g of 2, we're looking at our g of x equation, and we're plugging 2 in where we see x. Okay, so g of 2 here is negative 3 times 2, which is negative 6, and negative 6 plus 6 is 0. So g of 2 is 0. When we plug in 2 there, we get 0. So that's how we substituted g of 2 is 0. So we plug in 0 here, and then we find h of 0. So remember, this is telling us that x equals 0, and we look for the h of x. So we're going to look in this table. X is 0, and our h of 0 is 9. Okay, so here's the lesson, piecewise functions. So let's go over what a piecewise function is. It's a function that is defined using different rules for the different non-overlapping intervals of its domain. So here's a structure of a piecewise function. Let's talk about it. This is the name of the function, like always. F is the name of the function, f of x. We're using a single brace here to talk about the pieces of our piecewise function. So here, this is always the domain restriction. These two are the domain restrictions. Notice it's x, which always talks about domain, and these two are our function rules. So it's really saying f of x equals x squared minus 3 if x is less than or equal to 0, and f of x equals 2x plus 1 if x is greater than 0. So using the piecewise function above, we're going to complete the table. Now here's the thing. We're going to take a look at where all these x's land. So we're going to look at our domain restriction. Where is x less than or equal to 0? Negative 3 is less than or equal to 0. Negative 2 is less than or equal to 0. Negative 1. And 0 is that equal to 0 part. So the first 4 functions, we're going to be using this equation. And then the last 2, we're going to be using the bottom, which is 2x plus 1, because it says if x is greater than 0. Well, 1 and 2 are greater than 0. So that's when we're going to be using the bottom function. So like I said, we're going to use the top function, and all I'm doing here is plugging in the values. Okay, so all I did here was for x squared minus 3, I plugged in negative 3, so negative 3 squared is 9, 9 minus 3 is 6, negative 2 squared is 4, 4 minus 3 is 1, and so on. Now I get to 1, and 1 is greater than 0, so I'm going to start using this equation. Okay, so you have to look at the domain restriction, you have to look at your x's to figure out which equation you're going to use for that x value. And then you plug in 1 here, so 2 times 1 is 2, plus 1 is 3, and same thing here, 4 plus 1 is 5. Okay, we completed the table. Now we're going to graph it. So we're graphing every point. Now notice here, I graphed the first 4 points right here, right? And it's right here as well. It's hard to see that one. And then I graphed the last 2 points, 1, 3, and 2, 5 right here. Okay, now, when I have an x squared, which we haven't talked about yet, but when I have an x squared, it's going to be a U shape. So I don't know if you guys have learned that, but x squared is U-shaped. So notice how it doesn't even make a straight line. Even if I tried to make a straight line through these points, I couldn't. It's going to be a little bit of a curve at the bottom right there. And then this is a straight line because it just has an x. That x squared tells you it's going to be a curve, right? It's going to be a U shape. That x tells you it's going to be a straight line because there's no squared or anything. So that part's a straight line. Now, here's a point here that we need to make. So this note says we evaluate both functions at the break. So do you see how this is a break in the graph? Notice how before, let me take that back. You see how before we had this like piece right here that didn't have any numbers in it, right? So we need to write, notice here how I also wrote 2x plus 1. This is the break, which is at 0 in this case. So at 0, we're going to do both functions. We're going to do x squared minus 3. And we're also going to do 2x plus 1, and we're going to plug 0 into both. So if I plug in 0 to here, 0 squared minus 3 is is negative 3. And 2 times 0 is 0, and 0 plus 1 is 1. So I have two different points here. I have 0, negative 3, and 0, 1. So I have 0, negative 3, and I have 0, 1. And then I'm going to connect that line. Now this gets an open circle because notice there's no equal to sign here. And this one gets a closed circle because of that equal sign there. So we evaluate both functions at the break. So wherever both of the domain restrictions land, which is 0 in this case, we're going to evaluate 0 at this function and this function. The one that doesn't have the equal to sign gets the open circle, and the one that does have the equal to sign gets the closed circle, which I wrote here. And that's when graphing, okay? So let's take a look here. We're given these two functions, and we're going to evaluate when g is 3. So we have to figure out which one of these, for the domain restriction, where does x equal 3? Well, 3 is greater than 2, so we're going to use this function right here, g of x equals x squared, negative x squared. And so we're going to plug in 3 to our x. Notice this negative drops down, and we're going to plug the 3 in just to that x right there and square that. So when it's a negative x squared, we bring down the negative. We do not put the negative on the inside of the parentheses. Now we're going to evaluate 3 squared, which is 9, and bring down that negative. So g of 3 is negative 9. Okay, now we have g of 2. So this tells us the name of the function. So we're going to be looking at g of x. Our x is 2 in this case. 2 is not greater than 2. 2 is equal to 2, right? So I'm going to be using this function right here. And I'm going to plug in 2. And 2 plus 3 is 5. G of negative 4. So negative 4 lands less than or equal to negative 1. Negative 4 is less than 1. So I'm going to use the function g of x equals 2. And notice I'm plugging in the negative 4 to that x. But notice no matter what my x is in this case, I'm always going to get 2. X could be 5, x could be 100, x could be negative 50. No matter what, my function is 2 because I don't have any x's on this side. This is just a straight line. Okay, that's just a straight line. We're going to talk about that in step functions at the end. Okay, now here h of 10, well 10 is greater than 1, so I'm going to be using h of x equals 9x. Plug in 10. 9 times 10 is 90. And negative 5, I'm going to be looking at my h of x function. Okay, x is not less than negative 5. X is greater than or equal to negative 5. So I'm going to be using this middle function because of that equal to sign next to the negative 5. And then I'm going to plug in negative 5. Notice this time the negative goes on the inside of the parentheses because I have a negative 5. Here I had a positive 3, but the negative was on the outside. Here I have a negative 5, and there's no negative on the outside, so the negative 5 goes inside the parentheses. And negative 5 squared is 25. 25 minus 4 is 21. Let's try a few more. So now this one is saying g of h of 3. And I'm going to figure out what h of 3 is first. Okay, so I have to go back up to my h of x function right here, this piecewise function, and I have to figure out where x can be 3. Well, x can be 3 here because 3 is greater than 1, so I'm going to use h of x equals 9x, which is right here. I'm going to plug in 3. And I got 27. 9 times 3 is 27. So I know h of 3 is 27. I plug 27 back into here. And I'm going to say g of 27. So 27 is greater than 2, so I'm going to use g of x equals negative x squared. Remember to bring down that negative, plug in just the 27 to the parentheses. 27 squared is 729, and then bring down that negative. Now number 7 and 8, here this is h of negative 1. We start on the inside and move out. So we have to figure out, we're going to look at our h of x function, our piecewise function, and we have to look for negative 1. So negative 1 is going to be in between here, because negative 1 falls in between negative 5 and 1. So we're going to be using h of x equals x squared minus 4. Plug in our negative 1 inside the parentheses and square it, which is 1. And 1 minus 4 is negative 3. Then I'm plugging negative 3 in for h of negative 1 here. So now it's h of negative 3. I take that negative 3 and I look up here, and negative 3 again falls in between negative 5 and 1. So I'm going to be using h of x equals x squared minus 4. Plug in negative 3 for x. Negative 3 squared is 9, minus 4 is 5. And for number 8, h of g of 0, we start on the inside. We find out where x is 0 for our g function. So we're going to look in g of x. 0 falls in between negative 1 and 2. So we're going to use g of x equals x plus 3. We're going to plug in 0. 0 plus 3 is 3, which means g of 0 is 3. We're plugging that 3 back into g of 0, and it's going to be h of 3. And then 3 is greater than 1 for our h of x, so we're going to be using h of x equals 9x. And then we're going to be plugging 3 in, so 9 times 3 is 27. Okay, here, if it says determine the interval restriction, so now we have to decide where the interval is restricted. So we have to figure out which line is what. So remember when we're solving, this is the same thing as saying y equals negative 2x minus 2 and y equals x plus 3. My y-intercept is negative 2 and 3. These are both straight lines because they just have an x. They don't have a squared or anything. These are also straight lines. So we just have to figure out what is what. So here it says my y-intercept is negative 2 down here. And if this line keeps going, that's going to be, this line right here is going to intercept the y-axis at negative 2. So that line on the left right here is my first equation. So let's see where it's restricted. Well, it goes to the, remember we're talking about the interval restriction, which is always talking about the domain. It's talking about the x. So it goes to negative infinity in the x direction forever, because we're talking about x, so it gets smaller on the x. And it goes until negative 1. Because it's an open circle, we get a parenthesis after that negative 1. Then it starts again at 2 for x plus 3. Notice that my y-intercept is 3. From 2 to positive infinity for the x. See, I made that mistake right now. It's negative 1 because we're talking about the x. So negative 1 to infinity, okay? So don't look at the y like I just did. Look at the x values. We always look at the x when we're determining domain, okay? Which is the interval restriction is always going to be your domain. So we're always looking at the x. So it's from 1 to infinity. Negative 1 gets that bracket right here because of that closed circle, okay? And we can also write it as an inequality. This is the same thing right here as saying x is less than 1, negative 1 here. And then this one is saying x is greater than or equal to negative 1. Okay, same thing here. So my y-intercept is 2. So this line right here is talking about this first equation. Okay, so it goes negative infinity, and we're talking about the x. So negative infinity, and then it goes to 1. And then we're starting back at 1, and it goes to infinity. Okay, now they both get parentheses because notice there's 2 open circles in this time. So we can also write it as an inequality. X is less than 1, and x is also greater than 1. The domain and range of the piecewise functions is the total or union of the function parts. So, the domain is negative infinity to infinity, and the range is 0 to infinity. This is why. So from negative infinity, when we get to this point, we can jump up to this next piece because it's a closed circle and keep going. So do you see how the x goes from negative infinity, jump up, to infinity? That's the domain. My range, it starts at 0 for the y values, and it goes forever up. So my lowest point is 0, and my highest point is infinity. And they both get parentheses because of the open circle here and because of the infinities. Now my domain is from negative infinity to infinity, except x cannot equal 1 because both of them are open circles. Here it was a closed circle, so it kind of fills in that. You can think of it that closed circle fills in that open circle. We just jump from here to here. But here, we don't jump from here to here because they're both open circles. So we have to say that x cannot equal 1. And then our range starts at negative 1 and it goes into infinity. So negative 1 to infinity for the range. Okay, now a step function is a piecewise function whose value remains constant throughout each interval in its domain. So this is what this means. Look at all these functions right here. Do you see how they have no x's? It's f of x equals 2, f of x equals negative 3, and f of x equals 0. F of x is the same thing as y. So when we graph these, this is what it looks like. Well, y equals 2 here, y equals negative 3 down here, and y equals 0 here. They're just straight lines. They're horizontal lines. That's when you don't have any x at all, there's no slope. So it's just going to be a horizontal line. But there's restrictions. This is saying that x is less than 1. So we're going to start at 1, open circle, and go to the left. Here it's saying that y equals negative 3, or f of x equals negative 3 from 1 to 2 only. And they have equal signs, so it's going to be closed circle, closed circle. And then y equals 0 from when x is greater than or equal to, or greater than 2, not equal to. So we're going to have an open circle and it's going to go to the right forever. These are called step functions. So now we're going to write the step function here. Well, we're going to start off with f of x, and we look at the three places that they're going horizontal, so the y. So we have here, we have one at 5, we have one at 3, and we have one at 2. So 3, 5, and 2. They have no slope, so it's just a y equals 3, y equals 5, and y equals 2. And then we have to find out our restrictions. So here, we can write it as an inequality or as an interval notation. So where it equals 3, notice it's going to the left forever, and we're talking about our domain, so our x. So negative infinity, and it stops here at 2. It gets a bracket because this is a closed circle. So negative infinity to negative 2, or x is less than negative 2, if we want to write it in inequality notation. Then we're going to jump up to 5 here. So at 5, it's negative 2, and it goes until 3. Now, the negative 2 gets a parenthesis because this is an open circle. This gets a bracket because it's a closed circle. Or we can write it like this. So remember, we write x and then 2 inequality signs pointing to the left. This is saying x is greater than negative 2, but also x is also less than 3, less than or equal to 3. That's how we'd write it in inequality form. And then for 2, when f of x equals 2, which is here, it goes from 3 to 5, and they both get parentheses because they're open circles, and you can also write it like this. X is greater than 3, but it's also less than 5. Okay, so a special step function is the greatest integer function. This is how we'd write it. So f of x is equal to the integer directly less than x. Okay, so in this case, if we looked here at this graph, we're going to look for 2.7. So 2.7, we're going to start here, we're going to go 2.7. Okay, what is f of x equal at when x is 2.7? So 2.7 is somewhere in between 2 and 3. F of x equals 2. F of x equals 2. What about 1.9? So 1.9 is almost at 2, but it's not quite 2. And f of x equals 1 when x is 1.9. Then we're going to go negative 3.3. So negative 3.3 is in between negative 3 and negative 4. Remember that because we're going backwards. It's not in between 2 and 3. It's in between negative 3 and negative 4. So we're going to go negative 1, negative 2, negative 3, negative 4, and it's going to be in between negative 3 and 4. So if I wanted to, following the same pattern, I'm actually going to take that away for now. I would go open circle and then open circle. Okay, so now I can go negative 1, negative 2, negative 3.3 is going to be here, and it equals 4 if we kept going. 1, 2, 3, 4. Our f of x would equal 4, negative 4. Okay, so that is our special step function because it's the greatest integer function. Notice how you literally are, it's like walking down stairs, right? It's like walking down stairs. So it's going to be even throughout. The most well-known piecewise function is the absolute value function, and we're going to talk about this later, but just so you see this, we're going to be talking about the absolute value function as a piecewise function as well. And this is when f of x equals negative x and f of x equals x, and here's the domain restrictions, when x is less than 0 and when x is greater than or equal to 0.